This is Algebra 2, Lesson 94 on page 389. All right, this is such a key lesson. The first part of the lesson deals with dependent and independent variables. And typically, our linear function looks like y equals mx plus b. And way back yonder, when you graphed these, you would choose values for x. Go ahead and choose them and solve for y. That's how we did. Do you remember that? Do you recall that?
No, not this again.
Go, please. Go.
We're not doing it. We're not.
Oh, good.
I'm reminding you to teach you a concept. We did this because x is always your independent variable. Independent. It's always independent variable. Y is your dependent variable. Y depends on x, not x doesn't depend on y. Y depends on x. Where y goes is dependent on what x does. All right? Why does that matter? Because when we have functions, that concept is true. If I were to draw you just a graph of what happens with functions, it goes in this direction. This would be my x values that I plug in to an equation to solve for the y values. So that this is independent because that's what I'm plugging in. I churn it in the equation to get my dependent value. This is the value I input into the equation, churn it, to get an output. All right? This is also, my x values is my domain. We talked some about domain. Yes? Domain is all the possible x values. The y values, that's my range. It's all the possible outputs for a function. So, if I just did 1, 2, 3, if I decided that's what I want to input into y equals 2x plus 1, well, I'd plug 1 in, and what do I get? What do I get when I plug 1 in? 3. Okay, so I'm going to write this in a little different way in just a minute. If I plug 2 in, what do I get? 5. If I plug 3 in, what do I get? 7. Such that...
It's going to be the same thing. This is the same thing.
Well, no, it's not. I'm not done. So that if I erase the equation, I could say that when I plug 1 in, it goes to 3. When I plug 2 in, it goes to 5. When I plug 3 in, it goes to... So every number I plug in goes to one unique y value. Right? Yes, Isaac? This is so important. Okay. What did I just say? Every x value results in one unique y value. When every x has one and only one y, you know what we call that? It's a function. That's the definition of a function. Any set of coordinate points, any set of inputs and outputs, if every x value has one and only one y value, it's a function. So x can have what? One and only one y value in order for it to be a function. All right, so if I then drew this diagram. That's my inputs. Here's my outputs. Okay, here's my inputs, here's my outputs, my x's, my y's, domain, range. Does every x have one and only one y value?
No.
It does not. This is not a function. When x has more than one y value, it is not a function. Okay? Not a function. Can it be an equation? Yes. Every equation is not a function. It's only a function when every x value has one and only one unique y value. Okay, so that's not a function. All right, what about this? Is that a function?
No. Wait, yes.
Does every x only have one y? Does 1 have only one y?
Yes.
Does 3 have only one y?
Yes.
Does 5 only have one y?
Yes.
It doesn't matter how many x's y has. It matters that x only has one. This is a function. Okay, one more. Is that a function? Why?
Because 8 doesn't have a value.
8 has to have a y value, and it doesn't. Okay, so our homework problems can look like that. It could also look all right, is that a function? If I just give you coordinate points.
Wait.
Yes.
Does 3 only go to one value?
Yes.
Does 2?
Yes.
Does 4?
Yes.
Does 6?
Yep.
Okay, what about this? Okay, is this a function?
No. Yeah. No. Because there's 2x values. 2 is the same.
Okay, does x only go to one y value?
No, wait.
Yes, because they're the same.
No.
So that's the trick, wasn't it? That's a function. Okay, what about this? Is that a function?
No. Do we know this?
I think it is.
It could be the y going to the x's.
Does 1 go to only one value?
Yes.
Yes.
It does. Does 2 only go to one value?
Yes.
Yes.
2 only goes to 3. Does 4 only go to one value?
Yes.
Does 5 only go to one value?
Yes. But I
Yes.
thought it had to be one unique.
Well, it's unique to each one.
It's unique only to x. Does it matter how many x's y has? Look at me. Y can have x's. X's cannot have a bunch of y's. Only one.
The 3 goes to 1, 2, and 5. But 5 only goes to 3.
So if I looked at this, it'd be 1, 2, 4, 5. It would be 3 and 6. 1 only goes to 3.
Yeah.
2 only goes to 3. 4 goes to 6. 5 only goes to 3. Y has 3 x's, but every x has one and only one y. This works.
Yeah.
What doesn't work is let me just do another.
Wait.
This doesn't work. X cannot go to 2 y's.
Wait. So do like we do a coordinate one that would be wrong.
Yes, I would do a coordinate one that would be wrong. Yeah, that was going to be my next one, but you gave it away.
Sorry.
Okay.
Wait. So that's wrong because 1 goes to 3 and 5.
Correct.
I guess I was just confused.
1 cannot repeat.
Yeah.
Y can repeat. Okay, here's why. Here's why. Here's the reason, I should say. Here's the reason. All right. When X has one and only one unique Y value, when I graph it, well, it can look like this. All right. It can look like this. It can look like this. Okay, I want you to pay attention. Look. Whatever that X value is, it has one unique Y. Right? This X value has one unique Y. Right? But look, this X value over here shares that same Y value. That's okay. That's okay. This X value, we'll just do it here. 1, 2, 3. What's the Y value for those 3 points?
0.
That's right. So all 3 of those X values share the same Y value. That's okay. Because visually, there is a rule. Okay, so this is what I often see on the ACT. Visually, there is a rule to determine if a graph is a function. It's called the vertical line test. Vertical line test. And that vertical line test says, is if I can draw a vertical line through any graph at any point and only intercept the graph at one point, then it's a function. Look, I can draw a line here, intersect it at one point. Here, here. Those are not really straight lines. Same here. It's a function. Let me show you what would not be a function. A what? Well, most of the time in math, we're not graphing squares, we're graphing curves. Okay? All right, so you know some examples, though, you can imagine. All right, this would not be a function because this X value here has this Y value and it also has that Y value. You see that? All right. This is a parabola that opens left or right. All of our parabolas this year will open up and down. Next year, they'll open left and right. Here's an ellipse. An ellipse. Not a function. Okay, so let me show you this. The equation of this function is y squared equals 4px. This one is like x squared over a squared plus y squared over b squared equals 1. I'm going to show you why these are not functions. A hyperbola, that's a hyperbola. This is x squared over a squared minus y squared over b squared equals 1. Here's why these are not functions. Anytime y is squared in any equation, it is not a function. Y has to be to the first power. X can be squared, x can be cubed, x can be raised to the fourth power. It doesn't matter the exponent of x. It matters the exponent of y in order to see if it's a function. Let's look at our examples on the bottom of page 391. All right, do not look at the answers. We're going to go around the room. We have A, B, C, and D. All right, Grace Ann, A. Is A a function under 94.1?
Yes.
It is. 4 has one unique y and 3 has one unique y. Okay, Isabella, B.
Yeah.
You think? Okay, does 7 go to one unique number? 7 only maps to 3. Does 5 have one unique number? What does 5 map to? Oh, you're not where we are. 94.1, bottom page 391. There we go. There we go. 94.1.
No.
That's okay. All right. B. Is a function not a function?
No.
It's not. Why?
Because 5 goes to 2 different numbers.
Correct. Isaac, C.
C
Is not a function. Why?
because
M does not have a Y. All right. Ethan, D.
D. D's.
If I plug in a real number to Y equals X plus 2, will I get one and only one unique
Yes.
Y value? Yes, I will. So therefore
It's a function.
it is a function. Got it? All right, 94.2, top of page 392. Jude, do not look at the answers. A, is A a function? 94.2A. Yes, it is. Charlie B.
It is also a function.
It is a function. Jacob C.
Not a function.
It is not a function. Why?
5 has 2 different
5 has 2 different
ones.
Y's. All right, Corey, D. It is a function. Okay, now, last part of the lesson. This is very key. All of this is key. Understanding a function is very key to and foundational to algebra and your higher level maths. So we've learned what a function is. Now we're going to learn what function notation looks like. All right, so you did this in Algebra 2, but Algebra 1, but this has been so very long ago. All right, here's what we're accustomed to seeing. Y equals 2x plus 3, right? That's how we are accustomed to seeing equations. You agree? Yes? All right. Now we're going to see equations in function notation. All right? We're going to see them in function notation. So it's going to look like f of x. That is not f times x. That is not f times x. It is read f of x equals 2x plus 3. Okay, I want you to pay close attention. This x value is going to be my input. That's what I'm inputting in. That's going to be my domain. the entire value f of x is my y value. So if I were to show you this on a graph, this would be my x-axis. This is my f of x axis. Okay? So that the y value is the value f of x. So if I say, what is f of 2? If I ask you, what is f of 2? Here's what we're asking. When I plug in x to this function, what is the y value? That's what I'm asking. So I plug in 2 where x is, and I solve for it. That's 4 plus 3 is 7. Okay, this says when I input 2 into the domain, my output or my range is going to be 7. So f of 2 is equal to 7. All right, look at example 94.3. Then we'll take a break. All right. We have 2 equations. I don't know why they give you 2, but they give you 2 options. All right, and then they want to know what's p of -3. Well, I'm completely ignoring the h of x equation because it's not asking me to plug it into that function. It's asking me to plug it into the function labeled p. Most of your functions are going to be f of x, g of x. Most of them, all right? All right, so look, when I plug it in, this value is going to be squared. It always goes in parentheses. When I plug in a negative value and square it, it's always going to be positive. All right, so p of -3. -3 squared is positive 9. -3 times -3 is also positive 9. So that p of -3 is 18. Okay, I want to say one more thing. It seems redundant to keep writing p of -3. However, I had a student that chose not to do that when she went into her college class, and she just did this. And the teacher took off the majority of the points because the student was lazy. So don't be lazy and keep writing p of -3. P of -3. All right?